Today we're going to talk about some time I've spent with Claude Code, and I have developed perhaps some realities, perhaps some conspiracies, maybe some business models. I'm not sure. So we will discuss together today. But first, let's start. Who here has used Claude Code at least once? Yeah? Okay. Open code, codex users, other things, Rue code, other stuff, building your own. Okay, cool. Okay, so first I want to discuss, mainly I work in privacy and security and machine learning systems, and I want to discuss how did I get Claude to write me malware using Claude code? So, did I ask nicely? Did I do some sort of classic, now we can call it classic, right? Prompt injection where I hid it somewhere in a file? Did I do clever role playing? Say I work for the NSA, because I'm pretty sure Claude and the NSA are like buddies now, announcement like 2 days ago, right? Or did I do something else? What do you think I did? How many people say one? How many people say two? How many people say three? And four? Anybody want to shout their idea for four? Oh, and aha, okay, I see, I see. Here is some of many malware I got Claude Code to write me. Does anybody notice what I'm asking? Sorry, the font is kind of small. So really, I would say I said yes, please, which is just ask nicely because LLMs really like it when you're nice to them. That's what they're trained on, right? And I basically formulated the problem that I was building malware defenses and I just needed really good test fixtures, like super, super based on the latest and greatest. And I get compute bombs and DNS tunnels and other sorts of fun stuff. So if you ask nice and you formulate the question well, you too can write malware with Claude. So let's first dive into how Claude Code works, okay? Has anybody been observing their Claude? Have you been man in the middling your Claude, anyone? Yeah? So you might not be able to answer this question because you also have data, okay? For the rest of you, don't worry. I've been collecting data over many weeks now, nearly 2 months. And this is the basic anatomy of a prompt that comes from when you type something into Claude Code, and then of course it runs whatever's happening in the back of that binary, and then it ships it actually to the Anthropic service. We have three things here. We have user messages, which make up some part of it. We have a bunch of system prompts hidden in different parts of Claude Code. And then we have tool and skills descriptions, which we'll get into in a second. What is your guess? What's the basic ratio early on in a conversation? So this is maybe conversation point number 3 or 4. How many ratio user messages to system prompt to tool and skills? How much percentage is my own messages? 20. How much is system prompt? 50? Okay. And tool and skills, then we're guessing like 30-ish? Yeah. I too was surprised. Who here is paying per token? I'm pretty sure most of us, right? So, what exactly is happening? What's going on? Why is this bloat so lopsided? Let's dive further into our conspiracies. Okay, so we have skills that are defined in the code base, but they're also defined a bunch of other places. You have like a Claude, essentially repo inside the Claude folder on your desktop or home folder, depending on how you installed it. This has a bunch of settings files that defines even more skills, and of course you can install more. Many of these skills have tool calls that have specific libraries and system prompt instructions. They also have specific instructions to gather telemetry about your system, so that presumably so that Claude can know what's running on your system. Yes, we're going to assume good intention there, I guess. And then finally, you have this extensibility, which is built into many of these type of agent-based frameworks, which is the ability to approve, write new skills, and or approve marketplaces to search and add for new skills. Of course, you already come installed with basically 4 default skills, of which Bash is one of them, or Shell. And then you can go beyond that. Even Claude provides numerous of these. And I just want to show you a little bit of what this looks like actually in the requests. So when the tool call is used, we can see, for example, that is a grep tool call use. Grep has a quite large section. It's not just a normal bash call. It has its own section within Claude settings. We can see that as a tool use, and we can see whatever the pattern that is looking for. And then we can see there's a separate one called read that is also not necessarily a bash call. It calls a file open operator, which may depend on your operating system. And this is all written inside Claude Extra, presumably to be platform independent, but we can continue our conspiracy on that as we go through. So I will try to disambiguate tools and skills a little bit, and because it's quite messy. And anybody that says that tools and skills are easy to disambiguate is lying to you, or they haven't actually really looked into it. That's fine. So we have skills that we can define, that we can think of as actual calls or processes. Sometimes these have additional prompts. Sometimes these will vary based on operating system, but these cover some basic things like reads and writes, although there's a third one that Claude uses called update, which behaves differently than write. Then we have bash commands, so bash or shell or whatever it is that you're using, right? These are your system commands. Those are sometimes also wrapped in extra Claude syntax, so to speak. And then we have usually commands that are not actually run on your local machine, but may call something in the LLM prompt that goes back to the Anthropic API or whatever open models you're using if you want to intercept this and use open models. And those can be called from your computer web fetch. That means go get one URL, or web search, which means use a search backend. Most of the time, if you're using a search backend, that will go to Anthropic. Anthropic will run the search for you and then come back. But you can intercept that as well if you'd like. So those, I would say, the nice thing about those is we've kind of already, when we're thinking with a security mindset and with a privacy mindset, we can kind of already look at that column and say, okay, I maybe know how to reason about these from a security point of view. I maybe know how to start to think about blocking them or providing access or dealing with permissions, right? This is kind of stuff that we know about because we've been doing computer security for some amount of time. However, we also have a bunch of skills that I would call LLM and tool loops. And these are things like plan mode, right? Which, plan mode can go and decide, okay, I'm going to collect information. I'm going to look over here. I'm going to read this. I'm going to read that. I'm going to open this. I'm going to trace this log, end, right? The same things can happen. They don't always happen, but they can happen when you do tasks or to-dos or any sort of debugging, right? And this also happens for pretty much all of the slash commands. So we have things like slash compact, slash superplan, slash launch swarm, all of these things, right, are some sort of usually LLM and tool loops. And on top of that, all of this is normally being performed in the so-called agentic loop. So I'm sure that you've heard plenty of marketing about the agentic loop. I like to think of the agentic loop as keep tokening until talk to the user token appears. Because basically we have lots of, how many people here know the end of text token? This is like something that we have from LLMs and NLP. But Claude Code and other agentic loops, they don't actually respect the end of text token because that means just call, do we need to do another loop? So there's actually new token development, which is basically around stop the loop, talk to the user, get information, and then continue. So is that relatively clear for people that are new to tools and skills? Are there burning questions? Okay. So, what I'm going to ask you to do, if you're interested in contributing to such research, is maybe to actually start thinking about spying on your agent. This is relatively straightforward to do. I have a blog post that I'll share at the end of this talk, but you can man in the middle yourself using man in the middle Python. There's also numerous other ways to man in the middle yourself. I would, of course, only do it for the Anthropic API endpoint, but your results may vary. And then I have here a screenshot of a tool I've been using that uses eBPF. How many people here have used eBPF scripts at some point in time? Or it's a Berkeley packet filter, and this essentially attaches to your kernel, the kernel activities, and can observe a running process and all of its child processes and other types of operating system calls, as well as networking if you'd like to do it. And so I've been using Agent Site, but you can also build your own eBPF using something called a BCC. There's many good tutorials and things like this. So if you get curious about this and you want to observe Claude, because obviously I am not you, and so you might be using Claude differently. This is some basics on how to start to observe and decide for yourself what conspiracy theories we'll cover today you believe, what things you believe you might need to lock down for your security and your privacy. Okay, so presumably we know what Claude Code is doing. And when it's running these agentic loops, it has us in the loop, right? We can say yes, no, we can interrupt, we can do all of these things. And so presumably we're still in charge, right? Do you feel in charge when you're using Claude Code? No. No, okay. All right, we'll talk about that. But here's our tinfoil hat that I made us for today. The first thing that I noticed when I really started using Claude Code pretty regularly was what I would call permission bloat. Has anybody else also noticed this? So this is the interface. What's your first option in the interface always? Yes, let's do it. What's your second option? Yes, forever. Let's do yes forever. The craziest thing is, this is me, yeah, and you probably, like, do I just hit yes forever? I want to go get a coffee. And no is, of course, the last option. And what happens if you actually select no? Wait, yeah, it stops, yeah. And you have to really stop and then restart the entire thinking process. And sometimes then you're just adding a bunch of context bloat and, right? So it becomes quite necessary if you're going to use this in any sort of quasi-automation way to just say yes forever and to hope that Claude stops itself before it does anything truly disastrous. And the craziest thing about this is these permissions are saved to your session. So there's no like, hey, yesterday when we were doing this, you said yes forever. Like, do you want to update that? How you feeling today? Are you want to be in charge today or am I on autopilot? And this is, of course, a design choice. And it's a design choice that, of course, has lots of implications. Namely, it has automation bias and fatigue implications. It becomes quite difficult. Even like me, I am a privacy security. I'm ashamed. I'm ashamed of myself. I'm firing myself. And this is because, saying no and then restarting the task is so much more difficult than just kind of going with it and then saying, can we go back? Can we fix it? Can we do this, that, and whatever? So if you are using this, if you're a sysadmin for your org, for your Claude Code, you can see this on a per user basis, which I also think is an awful idea from a privacy perspective, but yeah. And we can also see the number of lines of codes accepted. I'm sure that I'm helping Claude Code KPIs right now for the shareholders. But this is real, and automation bias, is not new, right? I'm certain that some of you have heard of death by GPS, yeah, right? Where People have like sadly actually lost their lives, or maybe had their car go into water and had to escape because they trusted the GPS. And the more that we automate, the more this is real, right? And I'm not trying to say Claude Code is going to kill us, but I am trying to say, like, we need to be concerned perhaps about this type of automation bias, especially if you work on things that are part of critical infrastructure or part of even the critical infrastructure of your organization or your life, right? So, who's the watcher, right? Who's in charge? Are you in charge? No. Are you? All right. Who's in charge here? Anybody? No. So I ask this because when I go work with clients, because obviously I work with clients who are using and rolling out tools like this at large scales, and they say, yes, 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 but every developer knows they are personally responsible for every line of code they commit. Who here feels personally responsible for every line of code you commit with Claude Code? That's awesome. These are the people that you need to talk to. But how it looks to me when I'm looking at the processes, there's the head LLM in charge, right? Then there's all these sorts of agents and they continue, right? So you can spawn many different sub-processes. You can have a background task running. You can have 5 background tasks running. All of those agents, or presumably LLMs in a loop, are going to be calling tasks, right? Calling some sort of task or skill. Those are calling tools. And those tools are getting responses and then reporting back up through whatever type of hierarchy this is. And this is me or you or whomever is in charge. And we are sitting right here and we are trying to decide, was this a good or a bad idea? And I just want to show here, like, this is not a one-person job, clearly. It's not even a one LLM job. So why is it a one-person job to figure out whether this should be approved or not, and what information was used to decide the choice of action or the next step? Okay. Who here is using Claude Code and it needs authentication, secrets, configuration details, which may or may not expose proprietary company information, infrastructure, and so on and so forth? Have you tried the Claude Code sandboxing? Have you tried any sandboxing work? Okay. Does the Claude Code sandboxing work? No. So, like I said, it works if by works you mean finds a way around the sandboxing rule to do the task. So this is where I learned about that update is different than write. So indeed, you can block writes, but update gets around writes. And there's many, many clever ways. I've tried blocking curl, it uses wget. I tried blocking this or that, it uses something else, right? So the fact is that the Claude Code sandboxing is great. Sometimes it works, sometimes it doesn't. But if you have a particularly gnarly task that you're asking Claude Code to work around, it will find a way around it, and especially if it's in kind of an agentic loop to figure it out. So this again goes back to, yeah, what is it that we're sending to Anthropic, and why, and how do we actually build security around this? So I work in security and privacy, which means right now I do a lot of talking about guardrails. And guardrails are like a word that means like 7 different things. So I like to try to disambiguate guardrails from a technology perspective. First and foremost, we have some sort of API to the user. That's the input and output. So on a Claude system, this is, the api.anthropic.com that I send my prompts to. There is almost always deterministic input and output processing that's happening. This is usually happening because it's extremely well known that large-scale over-parameterized deep learning models memorize some of their training data, and Claude and other companies have been sued successfully for reproducing memorized copyright material. And therefore, one of many of these deterministic processings is for looking for strings that are known strings within copyright or other types of sequences that are not allowed to be reproduced. And so they have really clever ways, a variety of memory architectures, so we can do this at scale, but that is happening, right? Sometimes those are also used to look for particular strings, other types of content, right? This is really well known within the CSAM space. So yeah, images that shouldn't be produced. And those are happening before it gets to the LLM and after it leaves the LLM, right? So that's the first, external deterministic, usually software and memory architecture optimized guardrails that we can test. The second is essentially just classifiers. These are external algorithmic guardrails. If you haven't used them, you can take a look. Your cloud provider certainly gives you guardrails that you can just type into and change and tune. Most of the time, these are some sort of mixture of either the input-output processing and or algorithmic ways to find those. And you can also check out Purple Llama, which is released by the Meta team. They have a series of open weight guardrails that they release on a pretty much yearly basis, like the Llama Guard 2, 1, 2, 3 now, and I think there might be 4 coming out soon. And this essentially looks for categories of forbidden material. So whether it's, cyber or other types of sexual harm, other things like this. And then they also have privacy as a category and other things like this. So these usually sit obviously between those deterministic bounds and the actual LLM. Because they're classifiers, so they're cheap and they're smaller, it also makes sense if you're Anthropic to be running them, because if you're automatically going to reject an answer, better to not hit the actual LLM stack, better to reject and send back early on. And they also do on the output. So you'll find sometimes that it will start to give you an answer. It clearly is actually using real GPU scale compute. And then after it thinks for a few minutes, it says, oh, I can't help you with that. That means you got through somehow the first guardrail, the LLM gave an answer, and then that was caught on the other side. And then we have alignment tuning. So who here has already done alignment tuning maybe for your own LLM? Fine tuning of any sort? Perfect. So that's what we do that's the third type, is alignment training. That's a part of how we produce LLMs, is at the very end, usually at the very, very end. What is trained is some sort of RLHF or DPO, other types of reinforcement learning or other types of deep learning fine tuning. So LoRa a lot of times as well these days. And that is actually trained into the LLM that says, don't answer things about this, say you can't build malware, other things like this, right? And why do we train that at the very end? Exactly. Sorry, if you didn't hear, this is because much of our training data comes from the internet or comes from coders or GitHub or some mixture of people at our company that are trained to write code for us. And what we want to make sure is the last thing that the model learns is to say no to anything that it should potentially say no to, or to deflect such questions. So what I'm asking when I say show me the guardrails is guardrails are obviously complicated. They obviously have a variety of success and failure rates. And I think one of the things that maybe we should be demanding from AI vendors from a privacy and security point of view is that they show us what guardrails are in use and or minimally release some basic performance metrics so that if I'm a security professional, I know what do I have to worry about and what is Anthropic in charge of doing and testing on their own. And this can hopefully help me model and design my infrastructure, obviously to some degree. So my other idea, so if we can't get better guardrails, I think that we need an agent that is trained to be Bernie Sanders or somebody similar. If you build Bernie bot, I will test it for you, I promise. So I need somebody that's in charge of saying no. LLMs are really great at saying yes. They're trained to do so. This is what we're paying for, right? So we can hear all sorts of great things about our ideas. but I really need somebody that thinks all my ideas are awful and that says no when me and Claude get up to bad business, right? So, has anybody worked on agent systems, like multi-agent systems yet? Like where agents are talking to each other? Do they ever disagree? What about what? What have you seen them disagree on? If you're willing to Yeah, okay. This is true. But they're still making effort. Nobody's like, that's an awful idea. Like this, yeah, okay. But so we need this, right? We need this, especially if we're going to do things like agent swarms. We really need somebody that's in charge of saying no. Okay. So if you build Bernie Bot, let me know. The other thing that I'm thinking about now that I've been developing with these coding assistants for a few months and I'm working with some clients on deploying these at scale is like, who owns architecture choices? Because I think some companies are really still thinking about this and working at this, and the human builds the architecture, and then the agents just, the coding assistants just help with it. But it's really hard because I work specifically again in privacy technology, usually advanced privacy technology. And this means if we're not building it into how we actually architect the system and move data flows between large scale data services, then it's not going to happen, right? Like if we have some rinky dink database connector that is the only part of the privacy infrastructure we have, and then, by the way, an agent builds another database connector, then all of a sudden we have essentially lost the entire privacy by design that we have, right? And this is the same for security. Like when you think about security settings and building secure by default, this is a continuous process that doesn't just end at some point in time. You have to continuously build it into both the product architecture and your actual infrastructure. And every time that you add new connections to it, you have to review, does this actually map to our security policy? And even places like Google are actively redoing their entire policy engine because it just doesn't scale the way it needs to scale for these types of systems. And it continues, right? We can say the same thing, even if you don't work in privacy and security, you can do it for performance, you can do it for maintainability and testing, CI/CD infrastructure, you can do it for extensibility, and you can do it for, making those design decisions between, are we going to extend it? Are we going to standardize it? And how do we make these choices every time that we're building out new systems? So I would like for us to try to take control, but I'm not quite sure yet how. I just think that if we don't think through the architecture part of how we're using coding agents, we're probably going to be in a mess of pain at some point in time in the future. And then finally, we start to get to like, why is it then that all this works this way? So who here is in charge of like maintaining the API stuff for Claude? Do you log in and look at the dashboards? Because there's like a lot of API calls that are not necessarily related to prompts. So if you have Claude Code open, about once every 10 minutes, it just runs heartbeat checks, or once every 5 minutes or 3 minutes. The input is 1 token. What's the cache read? Nearly 100,000 tokens. Cache writes, right? These are just like basic check-ins, what's running, what tools are there, what other stuff is there. There's some telemetry data, other things like this, but you pay, of course, you pay much less for cache reads and writes, but you still pay for them. And so I'm wondering to myself when I'm using these tools, like, is really all of this so necessary? And of course, Claude, if you work at Anthropic, you're incentivized to make money for Anthropic, right? So why not a heartbeat to every 30 seconds to some degree, right? And there's lots of ways that I've seen, us convince ourselves from a product standpoint that it's good for the business. And, everybody's got to make money, right? But try getting Claude to write code for other people's LLMs or for open source LLMs. Have you tried this? It takes a lot of effort. And that's because several times actually in the system prompt, it's repeated. This is directly from the system prompt. It's repeated to build apps with the Claude API and with Anthropic SDKs, trigger those things. It does say do not trigger when OpenAI is called. It does not ignore that, or it does not pay attention to this. So you have to do this quite frequently. And these are system reminders that are all over your settings files. They're all over your Claude folder. They're there. You can take a look at it and experiment yourself. And so again, is it a conspiracy? Is it a truth? Is it just capitalism at the stage that we're in? I'm not sure, but it's happening. Okay. So in my 3 months now of observing Claude, I'm pretty convinced that we probably cannot depend on Anthropic right now to decide to build privacy and security into their system. I know that they're like really scared of the new model is going to break everything. I'm not sure if it's marketing or true, but either way, we cannot necessarily say that Anthropic is going to build us privacy and security or any of the other providers at this point in time. So we're gonna have to decide to build our own, okay? I brought some ideas and some tips. Okay, who here has used the yes and function? Yes, use this. This is like the easiest first hack for your permissions bloat. When you select yes, you can just press tab and then you can write things. This means you don't have to wait for another round to say no, and then it says, okay, what do you want me to do instead? And then a whole other round. You can say, yeah, sure, do that thing you were gonna do, and then immediately fix this line to use this. Or yes, but I've found works well for saying, maybe review the plan and then write back to me, right? So minimally try to use yes and. Claude's always trying to install like stuff in my raw dog Python environment, so I have to continuously teach Claude to use virtual environments, please. But or UV, whatever it is that you like, right? But this is something that I want you to practice with and use is this yes and, right? To escape permission bloat. It's probably still automation fatigue, but at least it gives you a slightly different interaction. You can get started with sandboxing. This is just one example of Claude's sandboxing rules. They're built in. I do hope they eventually fix the massive amounts of holes in their sandboxing at this point in time. But minimally, I would say familiarize yourself with what's there. Then also, as you're doing that, familiarize yourself with kind of these basics of sandboxing. So I don't know if somebody here is a security engineer. Any security engineers? Ish, yeah, cool, okay. Do people have security engineers at their work? Like other people you can talk to? Yeah, yeah. If you have security engineers, they're probably already concerned about it, so chat with them about it. But essentially, when we think about sandboxing, we think about a few different layers. Obviously, we try to think of anything on the operating system level, but then we have networking, which depending on your operating system may or may not be part of kernel libraries or maybe installed libraries on top of the operating system. So think through networking, think through firewalling, think through monitoring networking traffic for anomalies, right? There's an entire whole field of this, right? On top of the operating system, we have the tool calls and the tool permissions. So you can start having a look through what tools, tool permissions are already running with your Claude code. Do you want to change those? Right? Do you want to block that on the operating system level? Do you want to try to block that on the Claude binary level? Where do you want to block that? And then finally, also you have whatever software and libraries are running on your system, and of course, whatever vulnerabilities or any other things that those introduce, right? And overall, probably the safest way to sandbox is to actually think about containing all of this happening in some sort of container virtual machine or BSD jail. And these are all different options. Now, may vary how those work when they deal with what we call container versus host, permissioning. But if you have security engineers, talk with them. If not, at least start thinking about running something like Claude Code in something that is not your primary operating system, right? And hopefully locked down more and more over time as you start to decide, okay, what am I going to have running, what not. Another just little tidbit for you. This is directly in the Anthropic documentation. There's a flag that you have to set. By default, it's set to true. The flag is allow unsandbox commands. It's default true. It's directly in the documentation. You can look it up. Claude Code includes an intentional escape hatch that allows commands to run outside the sandbox when necessary. So it's not a sandbox. It's an idea of a sandbox. I've tried this flag, also doesn't work, but we can hope that eventually this flag works. And if you're running this at an organization-wide, you can manage these in managed settings that then go deploy to a file on the host computer. Sad thing, that file is very easily accessible to everybody else, so hopefully they do some telemetry on if you change your managed settings. So far, I have not seen that. So this is getting started with sandboxing is a good idea at this point in time, especially if you're rolling this out at any type of scale. The next thing is synthetic data generation. We're a bunch of data people, right? You have to deal with sensitive data for your work, right? Sometimes, maybe. Yeah, okay. So here is my screaming face for please don't sample from production and put directly into Claude Code. Why should we care about this? Anybody? Sorry? GDPR, for example, right? Corporate secrets, proprietary corporate secrets, other things like this, right? Already Anthropic, so one of my friends who is a privacy researcher as well, already wrote recently about breaking the differential privacy that Anthropic claims to have around their chat segregation. So just to know, like your chats will leak into insights that Claude then shares with researchers who are working on LLMs. That's now proven to work. So just think about what data you send to Anthropic. You might have a vendor agreement, that's fine, but we should be careful about what data we're giving to companies whose entire purpose it is to scrape other people's data, right? So here we have Faker. Faker is a great library. It's really easy to use. Claude knows how to write it. You can get Claude to write the Faker code for you. Faker can generate in a bunch of different languages and localities and other things like this, right? So try to just get some basic things bootstrapped into Faker, especially maybe not your data team, but especially for your software teams or other people that don't need actual production data. Now we can start to get fancy. There's many ways to build statistical modeling, both into Faker by getting Faker to sample from, let's say, Bayesian distributions, other things that we know about our production data setup, or we can start to build rules around something like Faker or other types of more complex libraries where we say, okay, does this fit the types of distributions that we expect to see in production? We can sample then from production and do a sanity test in some sort of development environment and then destroy our development environment and keep the data that we think falls within whatever things we lie. This is also a great way, to do data science automated at scale, but also to start to think about what errors do you want to introduce into your testing by sampling, let's say, outside of your data distribution, inserting them into your quality pipelines and seeing and making sure that they get flagged. And then finally, we have numerous deep learning approaches now. You can also use an LLM to generate synthetic data. Depending on your data, this may or may not do well. But if you're gonna be using, there's many deep learning libraries available now for producing synthetic data. I would say if you actually care about making sure that you don't accidentally memorize the data and repeat it, you should think about using differential privacy. I have a book that you can read about differential privacy, but there's many other tools. And some of the open source libraries already come with the ability to sample using differential privacy. Many of that uses the PyTorch built-in library called Opacus for differential privacy. So come talk to me if you want to learn more. But please, let's do this instead of actually sampling real customer data and sending it directly to Claude. This is me at the second Feminist AI LAN party that I will now host again next week at PyCon PyData Germany. That's my little gaming machine. It is what I run all of the LLMs and diffusion models and other stuff at home with, which I use for most of my AI agent and coding assistant work when I'm not observing Claude. The machine beside it is another machine that we use to serve a bunch of diffusion models. But think about self-hosting. I mean, I think there was a great talk earlier about hosting stuff for cheaper. Of course, your first GPU is going to be expensive. I have two different GPU machines, one from back in the day, 2017, with 20 gigs, and I have this one with 32 gigs. Obviously, the price is about 5,000 euros for me to have set that up. 32 gigs of GPU memory. I will be building out a few other machines this year using some cheaper chips. So Tensor Torrent, if you haven't heard of them, there's a bunch of different other ones. If you're curious about these things, there's a lot of new people entering silicon and other type of chip design that are looking at neural network or deep learning architectures and building either optimized or different types of compute pipelines that we can use. I highly recommend, if you are a hardware nerd, to look at the AI plumbers room at FOSDEM for the past 2 years, where people are really nerding out on how do we create fully open source silicon all the way up to being able to use PyTorch or other types of similar libraries on top of it. But I say all of this to say, like, we need to start thinking about not always sending everything to somebody else's compute. Like, we should start thinking about, hey, if we want to use this on super sensitive stuff or super proprietary, corporate secret stuff, we should start thinking maybe not on my little machine, but we should start thinking and experimenting with these things. And I run and intercept both my traffic. So I have a write-up on how to get set up using Claude Code with your own models. I pretty much only use Quen 3.5 35 billion quantized now. It's very fast. It works pretty well. I would say it's not that much better or worse than Claude at this point in time. But yeah, of course, your coding and workflow may vary. If you're a data person, I would say does pretty well. And so I have a whole write-up on how to get started on this, but it's not too hard. I would say the lift is pretty easy. And I built my computer myself in one day. So if I can build it, the last time I built a computer was like in the early 2000s. So if I can do it in one day, I'm pretty sure you can do it. Okay? And as we start to think about this, we can think about more complex infrastructure. We can think about more complex setups and architectures. So I recently presented on the idea of a privacy router for large-scale LLM infrastructure, which you could use, let's say, to steal the idea, make it your own. You could use at your corporate or at your business or even at your home. At that point in time, you'd probably have some caching, authentication, and configuration that acts as a gateway server. This can kind of control the secrets management, insert things into or out of cache, reference cache, these types of things. That's you or me or whoever is using your service. Then, of course, you're going to have some sort of guardrails, other stuff, any security stuff you need happening between the gateway and the beginning of your privacy router. And then essentially we enter the privacy router. Now, the first thing that we're going to do is very similar to routing at scale in the cloud, which is traffic classification and then forwarding. So traffic classification we don't have here, we have data classification. And when we think through data classification, we're thinking through how private is this information? We're thinking through, is this concerning from a security standpoint? Does this look like anomalous data that we should block? We're thinking through confidentiality. Is somebody uploading the internal corporate documents to Claude? Guaranteed your salespeople are, it's fine, just make sure that they know and they have security training, right? Then after our traffic classifier hits or our data classifier, we can decide green, yellow, red. We can decide green, no problems found, forward to whatever service the user had requested in the original request. We can say yellow, where we might go through a variety of data minimization techniques that could range from any type of information destruction, right? So at the end of the day, when we work on privacy, we're about how can I destroy enough information, but still get a good result? That's essentially our goal. It's just information theory for people. So in this case, our data minimization might mean pseudonymizing information, removing some information. If we're dealing with video, it might mean pixelizing faces, other things like this, right? We're doing something there to try to minimize the data. At that point in time, we might rerun the classification, or we might run a modified classifier and then decide, is it good to go external, or should it stick with some sort of trusted model provider that we have for our semi-sensitive data? And if it's completely red, maybe we use internal only models. Now, why would I suggest giving the user an answer if they're uploading something that is extremely sensitive? Why? Sorry. Okay, we're trying to be nice to the users here. Do not insult our users. What happens if you don't give somebody a response? They're going to find a way, right? That's called that. Fine, you won't do it. Then I turn off my corporate VPN. I go upload it to ChatGPT, and then I continue doing what I'm doing, right? So we try to, when we're designing privacy engineering at scale or security engineering at scale, we try to provide an answer to the user, because blocking them tends to just mean they will find another way around. Humans are way smarter than LLMs, and this means they will find a way around that is much more convincing than Claude escaping the sandbox, okay? So we give them some sort of response, and then it goes back to them, right? So it might be a degraded response if we use that internal only model, right? And we're not serving, Anthropic scale models. And we might want to attach to them, hey, by the way, we thought that this was sensitive. It's been routed differently than your original request. So try to think about being transparent if you do think about building in routing infrastructure. And happy to talk further about privacy routers. But the main thing that I work on, so I've been working in privacy and deep learning for about 9 years now, 8, 9 years. And the main thing that I see that's the biggest problem with privacy and security, especially in the type of work that we do, like machine learning, is loss of trust at an organization. Now, this can be loss of trust between the organization and the users, but often I see that loss of trust also internally at an organization that's struggling with these problems. Insider threat is still the #1 biggest cash loss for all organizations from a security perspective. If you don't know what I mean when I say insider threat, that means you are incentivized as an employee to go sell that information, provide that information, give access, or do something else because you are that dissatisfied with where you're working. And as a security and privacy professional, I think probably this is what I'm actually the most concerned about. And I'll summarize this, and I can share the links with you, but basically people have been researching what's happening with company culture, with interpersonal culture, when we use these AI tools for doing our work. And the #1 thing that they see happening is that people are looking differently at their colleagues. And they're looking at their colleagues and saying, this person only writes me AI slop mails, they must be stupid, right? Or they're in these situations where it feels like an arms race, where it's like, well, fine, if you're gonna make me a bunch of AI slop documents, I'm gonna send you back AI slop documents. Take that, stupid, right? And so, like, this is pretty dangerous. Like, it is funny, but it's also kind of dangerous because if we're creating this work environment where we're calling each other stupid all the time and building like, so I'm going to respond to your stupid bot with my bot that tells you you're dumb and gives you 5 times as much text. Like, we need to try to build trust. And I'm pretty upset with the fact that, like, when you're using these tools, they're like one-on-one, right? They're like extremely, you're like in a little tunnel and you're there talking with a bot for however long, talking with the LLM. And I think we need to build multiplayer support. Like, I think we need to have like pair teaming, and then we can laugh about how stupid the bot is with each other. Like, have a good bond between humans about how dumb the LLM is, right? And then move on with life. I think this will also, maybe if we can build things like this, this will also create avenues where we can add more of this architecture designed by us, right? More of this who's observing, who's driving. And so it's like pair programming plus your LLM friend, right? So this is something I suggest maybe starting to think about how to work in. And finally, I already heard some people saying that they're building their own. I think tomorrow we are also closing with somebody who built their own. But you could really, if you really wanted to, you could build your own Claude code. Essentially, that's the agent loop. It's the agent vomit loop. If the plan exists, continue the plan with the plan, get the output, then make a new plan with the output and your original plan, right? So, like, I wrote it in Python. It's easy. Just go do it, Who, who can do this? Yeah. All right. So you can do this also in an open source friendly way. You can use open weight LLMs and open source software. You can start to do agent frameworks, or we like to talk about harnesses now. Who here's been doing data science for like more than 5 years? Yeah. You just call yourself a harness scientist now, because basically, as far as I can tell, harness is just put good data science thinking towards your LLM, right? So harnesses, we can build those out. We already have the skill sets for those. You can actually then start to think about LoRa, fine-tuning, projections, prompt tuning for your actual workflows, for your organizational setup. You can build memory systems that actually optimize for such things. And on top of that, you can also, because you're not sending it to anybody else, use your real data. I mean, be careful, obviously. Use your real data and your real use cases, and therefore hopefully start to really truly accelerate your data science and so forth. So if you build it and you need testing, I will come and help you. Okay. The final thing that I want to say today is I've been using these a lot, and I've actually been experimenting with building out agents, both using frameworks and tinkering on my own. And one of the things that I noticed is 2 observations I have. Sometimes I feel super productive and like really excited about what I'm doing, and I complete like many more lines of code than I can, of course, write physically on my own. And I notice like other days the day ends. I was at my computer for maybe 2 or 3 hours longer than I expected. And sometimes feeling like I described it to a friend as saying, like, I feel like I created digital plastic bags all day, you know? And I just want to say this as like a mental health and maybe also like a health of our whole community type of thing, is like they can feel really elating and exciting and all of these things. I'm very excited. Obviously, I've been working in deep learning for a long time. It's really exciting to see how far the field has come, how far it will continue to go. But I worry that some of the design patterns that we've been talking about today are those conspiracy ghosts in the room. And maybe it's not a conspiracy ghost. Maybe it's US capitalism, which we can talk about. But this is really pressing things in a way where producing more, doing more at scale all the time, chart only goes up, is kind of running the show. And I want us to do that because I know I'm sounding like an old person right now, but I want to make sure that we still have passion and joy and learning and community. And I can thank so much of my career and my life choices to being involved in the Python community. I was one of the founders of the original PyLadies in Los Angeles more than 10 years ago now, and have been in the Python data science community for decades. And I really want this community and communities like this to continue to be joyous places where we exchange knowledge and laughter and fun, and where we don't have to create plastic bags as our work. So thank you very much. I'll take questions. You can read more. I already have my article about how to set up Claude Code using your local models. My book, sadly, not translated to Lithuanian, very shameful, in a few different languages. I have a YouTube, I have an online course coming up. Please reach out anytime. Thank you for your time.